Um, another another part related to the array I would like to show you is this. I decided to create an array of 10 elements, okay? So obviously this allocates, it's pretty simple, right? So it just goes ahead and again, in the local scope of main, right? It allocates this array of 10 integers in memory, and each integer is accessible by their index, like 1 and 2 and 3 and 0 and 9, right? And then if you try to use 10, you're in danger because you're referring to potentially location in memory that may not belong to your program, or if your program runs inside a microwave, there may be not even physical memory with index 10, okay? It just doesn't exist, but you're trying to refer to it, you're in trouble. Obviously, your attempt will fail in some kind of catastrophic, unpredictable way. Okay. So you have to be careful with the boundaries, and typically you need to keep track of the size of your arrays. But how about array initialization? With normal variables, I can initialize them simply in the assignment style, adding initializer next to the variable name and just say, hey, x equals 1, 2, 3 to begin with, so it has a known value. As I begin to use x, I know what's stored there, and it's all expected and very predictable. Now, with arrays, you have to use, the syntax is the same way, but you use something that's called array initializer. And first day of this class, we said that the curly braces usually specify an area in memory. For instance, our functions such as main is using curly braces at the beginning as at the end, because when this program is compiled and then when it's loaded into computer memory, somewhere here down part of our program, right, we have this memory segment named text, okay, and executable code goes there, and anything that's been compiled for main will be stored in this memory location. So definitely when we use curly braces around the body of our function, basically this specifies the scope of the function. We say, okay, whatever goes in that function can be understood as the body of the function, and when it's compiled, it goes into computer memory, and it's a specific area of computer memory. But very similarly, the array is kind of the same idea. It's using a part of memory, and if you want to initialize it, again, the curly braces are used to essentially aggregate a list of values which can be used to initialize this block of memory. Remember, in C, arrays are nothing but blocks of memory. Each integer is positioned next to each other. Each integer inside this array has a unique number. If you want to use subscript access to it, use 0, 1, 2, 3, 4, 5. Okay, so, but the curly braces like this are used, curly braces are used to initialize the array. And I could have went to say 10, 20, 30, right? I could just provide the numbers and go all the way through to initialize it. But I'll keep my initializer short to just only 4 values. If your array initializer is short of all required, or not really required, but all elements in this array, then the rest of them are actually initialized with 0. If you do not provide array initializer, your local array in this function main will be initialized with whatever is in that block of memory before function name was invoked, which means pretty much garbage values, okay? Unpredictable. At the same time, when you do provide initializer for your array, the elements are initialized, and it's going to say, okay, index element with index 0, of course, is going to get 10, and then 20, and then 30, and then 40. The rest of them will be initialized with zeros as if I did this, right? If I just went ahead and specified the individual zeros, the array would be initialized. Now, I have to be careful to count this, right? So this is like 5 elements, and this is another five elements, and I have an extra element. You cannot provide extra elements in your array initializers. It's not allowed. If I try to compile it, this will be error. But doing something like this is completely unnecessary because I can just omit all zeros and the rest of the elements will be initialized with zeros. It's also possible to leave out the size of the array. If we do this, the array size will be computed from the length of the initializer. In this case, this is equivalent to doing this, 4 elements, okay? But if we go back to 10 elements, then the rest of the elements are filled with zeros. It's also very common practice with arrays to, if you want to initialize all elements of the array to 0, just to say this. Specify first 0, and the rest of them will be initialized with 0, right? But be careful, because if in this case you just want to get a default size of your array, the size of the array will be 1, because there's only one, there's only one element in the array initializer. So we go back to 10, then you can do it this way. You can even initialize everything with zeros if you do this. Depends what your style is. An empty array initializer suggests that all elements of the array should be initialized with 0. My style usually is to just remind myself that I'm initializing everything with 0 and specify the initial 0 inside the array initializer, right? So very simple notation and very limited in terms of what you can do with this. I mean, it's pretty rudimentary, pretty fundamental and basic function, not function, but the notion of arrays in C is they're simply blocks of memory subdivided into the data types that you create.